Space junk. Our planet is not the only thing we treat like a trash can. Space is slowly becoming one too. Right now, there are millions of pieces of man-made debris circling Earth. Over 30,000 of them are bigger than 10 centimeters, or about the size of a fist. That doesn't sound like much, but keep in mind they're moving at over 28,000 kilometers per hour. At that speed, even a bolt could tear through metal like a bullet. The real problem is that debris creates more debris. Every time two objects collide, they shatter into countless new fragments, which then go on to smash into other satellites. Scientists call this the Kessler syndrome. In simple terms, it means one crash could trigger a chain reaction that turns Earth's orbit into an unstoppable shooting gallery. NASA already has to dodge space junk on a regular basis. Since 1999, they've changed the course of the International Space Station 32 times to avoid collisions. Now, most people assume this is a problem they'll never face, since they don't exactly have plans to visit space. But debris doesn't always stay up there. Large pieces of rockets and satellites have fallen back to Earth, sometimes landing in people's backyards. Most of it crashes unnoticed into the ocean, where it just blends in with the rest of our garbage. Cosmic voids. The universe isn't just full of stars and galaxies, it's also full of nothing, and I mean literally nothing. Cosmic voids are gigantic empty regions of space that contain almost no galaxies, no planets, no stars, no moons, no asteroids, not even a McDonald's, just vast stretches of nothingness. Some of these voids are so huge that they span hundreds of millions of light years across. To give some perspective, our entire Milky Way galaxy is about 100,000 light years wide and contains at least 100 billion planets. Now picture a void like the Bootes void, which is 330 million light years wide. That means you could fit thousands of galaxies inside it, but instead, there's practically nothing there. These voids are part of the cosmic web, where matter clumps together into filaments and clusters, leaving behind enormous gaps in between. If you were unlucky enough to take a space trip through one, it would be the longest, loneliest road trip in existence. Unless, of course, you're an introvert, then it's basically paradise. Dead galaxies. Galaxies are supposed to be busy places, giant star factories constantly pumping out new suns, but not all of them keep the lights on. Some galaxies run out of the cold hydrogen gas needed to create stars, and when that happens, they die. Astronomers call these quenched or dead galaxies. When a galaxy dies, no new stars are born. The old stars slowly burn out, leaving behind a cold, dark husk that becomes little more than a cosmic graveyard. For a while, dead galaxies glow faintly red, powered by their last scraps of fuel, like embers fading in a fire pit. But eventually, even that disappears, and they go completely dark. The scary part is that this isn't rare. It's the eventual fate of every galaxy, including our own Milky Way. One day, all of its stars will burn out, and no new ones will take their place. On an even larger scale, cosmologists believe the entire universe itself may one day run out of usable energy. This theoretical stage is called the Dark Era. If it happens, the universe won't end with an explosion, but with an endless, frozen silence where no new light will ever appear again. Planets. NASA estimates there are at least 100 billion planets in the Milky Way galaxy alone. Across the observable universe, that number jumps to over 6 sextillion. That's a 6 followed by 21 zeros. For comparison, there are supposedly more planets in the universe than grains of sand on Earth. And if you've ever been to a beach, you already know that's an impossible number to fully grasp. But the real nightmare isn't the number of planets. It's how many of them are completely uninhabitable. Take Jupiter, for example. The biggest planet in our solar system and a death trap in every possible way. It's a gas giant more than 1,300 times the size of Earth, wrapped in storms so violent they could swallow our entire planet. Step into Jupiter's atmosphere and here's the checklist. Radiation, dead. Atmospheric pressure, dead. 400-mile-per-hour winds, dead. Struck by lightning, dead. Try to breathe, definitely dead. And Jupiter isn't even the worst case. Other planets out there rain molten iron or glass, burn non-stop under oceans of lava, or are locked in permanent ice. Some are drowning in water with no land at all. Others are so dark you'd never see the surface. There are even planets with hurricanes larger than Earth itself. In fact, that last one is still Jupiter, which, in case it wasn't clear, sucks. Aliens. Aliens have been terrifying us long before we had any proof they exist, thanks mostly to Hollywood. Movies like Alien, Signs, Predator, and even Killer Clowns from Outer Space all drilled the same idea into our heads. If extraterrestrials show up, we're in trouble. When Hollywood finally tried to make a friendly one, they nailed the look, but the personality didn't exactly hold up. But here's the scientific reality. The term alien doesn't automatically mean a tentacled monster. It simply refers to any living thing that didn't originate on Earth. That could mean something something microscopic, like bacteria, or something far larger and far more advanced? The truth is, we don't know, and that uncertainty is what makes the idea terrifying. Statistically, with trillions of planets out there, it's likely that life exists somewhere else. The question is whether it's simple and harmless, or powerful enough to make us look like ants. The scariest possibility isn't invasion, it's the unknown. We wouldn't know what they want, what they value, or even if they'd notice us at all. And given the state of Earth's orbit, cluttered with trash and broken satellites, first impressions probably won't work in our favor. Gamma ray bursts. Gamma ray bursts, or GRBS, are the most powerful explosions known in the universe. In just a single second, one can release more energy than our sun will produce in its entire 10 billion year lifetime. They occur in a few different ways. When a massive star goes supernova, when two neutron stars collide and collapse into a black hole, or when a black hole swallows a neutron star. The result is a focused jet of radiation so bright that, for a few moments, it outshines entire galaxies. The bursts themselves can last anywhere from a fraction of a second to several minutes, but their effects are catastrophic. If one ever hit Earth directly, the radiation could strip away our atmosphere, destroy the ozone layer, and trigger a mass extinction. And the worst part? They're invisible to the human eye. We would never see it coming. No warning, no time to prepare. Even from thousands of light years away, a GRB could knock out satellites, fry electronics, and collapse global communication. At closer range, it would sterilize the planet. Thankfully, our sun isn't capable of producing one. But elsewhere in the universe, these invisible cosmic weapons are going off all the time, colliding galaxies. With billions of galaxies moving through the universe, collisions are inevitable. In fact, our own Milky Way is already on a collision course with the Andromeda Galaxy. The impact will happen in about 4 to 5 billion years, long after Earth as we know it is gone. But the event itself will reshape both galaxies completely. When galaxies collide, their gravity pulls them together, stretching them into new shapes. Surprisingly, stars almost never crash into one another because the space between them is so vast. But the disruption throws entire solar systems out of place. Planets can be ripped away from their stars, flung into interstellar space, or captured by new suns. For any world with life, this shuffle would be catastrophic. We already see this happening in deep space. Astronomers have captured images of galaxies mid-collision, twisting together like strands of cosmic taffy. Over millions of years, they eventually merge into a single larger galaxy. For the Milky Way, that future galaxy has already been named Milkomeda. A beautiful name, sure, but one born from total destruction. Supernovae. Supernovae are the largest explosions humans have ever observed. For a short time, a single star going supernova can shine brighter than its entire galaxy. There are two main ways a supernova happens. The first is when a massive star runs out of nuclear fuel. Without the energy to resist gravity, the star collapses in on itself and detonates in a blast of unimaginable force. The second occurs when a white dwarf star siphons too much matter from a nearby companion, pushing it past a critical mass until it collapses and explodes. The destructive power is immense. A supernova can obliterate everything within about 30 to 50 light years. That means any nearby planets are instantly sterilized. For perspective, our own sun is just over 4 light hours away from Neptune, so even at light year distances, these blasts reach across staggering scales. Astronomers rely on supernovae to measure cosmic distances and study the evolution of galaxies. But from the perspective of life, they're a death sentence. Entire ecosystems, atmospheres, and even planets themselves can be wiped clean in a flash. They're among the universe's most violent reminders that stars don't die quietly. They take everything around them with them. Black holes. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. They form when massive stars collapse under their own weight, compressing all their mass into an infinitely dense point called a singularity. Around that singularity is the event horizon, the invisible boundary where escape becomes impossible. There are two main types: stellar mass black holes, which are a few to a few dozen times the mass of the sun, and supermassive black holes, which can weigh millions or even billions of times more. One of these supermassive giants sits right at the center of our Milky Way, quietly devouring matter that drifts too close. The terrifying part isn't just their size, it's how little we truly understand them. To us, black holes are completely invisible. The only way to detect one is by observing how it distorts and consumes nearby stars and gas. And if you were to fall in, physics stops giving clear answers. The leading theory is spaghettification, where tidal forces stretch you into a thin strand before tearing you apart atom by atom. Others speculate black holes could act as wormholes or gateways to alternate universes. What actually happens inside is one of the greatest unsolved mysteries in science. All we know is that once you cross that horizon, there's no way back. The size of the universe. The most terrifying thing about the universe isn't a black hole or a supernova or even a gamma ray burst. It's the sheer size of the universe itself. Start at the human scale. You're standing on Earth, one planet orbiting a star in a solar system with 8 planets. That system sits in a small region of space called the local interstellar neighborhood. Zoom out and you find it's part of the Milky Way galaxy, home to at least 100 billion other planets. The Milky Way doesn't exist alone. It belongs to the local group, a cluster of more than 50 galaxies bound together by gravity. That group sits inside the Virgo supercluster, which contains thousands of galaxies. Zoom out again and you reach the level of superclusters, which form part of the cosmic web stretching across the observable universe. The observable universe itself is 93 billion light years across. And that's just the part we can see. Beyond that horizon could be infinitely more. Galaxies, voids, or realities we'll never reach. The unsettling truth is that no one knows if the universe has an edge or if it goes on forever. Compared to that scale, Earth isn't just small, it's invisible. Every achievement, every civilization, every life that's ever existed, all confined to a single dot in a cosmos so vast we can barely comprehend it.